This is section 3, random variables. We'll be talking about random variables, and we'll be moving into the normal distribution. So we'll start with discrete random variables. A random variable is any variable that varies in some way that we can't control or predict. The only thing we can do is talk about the distribution or how it's dispersed. The first is a discrete random variable that can only take on certain values, 1, 2, 3. A good example of this is the number of trips to a grocery store. I can't do 1.5 trips to a grocery store. I can only do 0, 1, or 2, or so on. A continuous random variable can take any range of numbers, and it can be even irrational numbers between integers. So it would be the length of time that a grocery store trip would take. Good example, another good example is a digital clock versus an analog clock. A digital clock will tell you to the minute or to the second. An analog clock is actually continuous, so it would move between those values. So now we can rewrite our figure here that we saw in section 1 to include in the interval and ratio or quantitative data we can show both discrete as well as continuous. I'd like to provide an example here. Let's assume that a salesperson can make a sale on 20% of his sales contacts, and in one given day he or she is only able to make 2 calls. So maybe they're traveling or have some reason that they can only make these 2 calls. Well, we have this discrete random variable that takes the place of a 0, a 1, or a 2, because a person can make somewhere between 0 sales in a day or can do as many as 2 sales in a day. So what we want to do is look at each possible occurrence. So let's say that the person can make 0 sales. Well, how is it that the person makes 0 sales? The probability that a person makes 0 sales is 0.8. So if the person makes 2 sales calls, or the probability of making 0 sales in 2 calls, that would be the probability that they make a sale, they do not make a sale in the first call, times the probability that they do not make a sale in the second call. So there's a 64% chance that the person won't make a sale in any given day. Let's ask, what is the probability that the person makes 1 sale? Well, that would mean that the person would not make a sale in the first sales call, 0.8% chance, but they would make a sale in the second. There's a 20% chance. Plus the probability that they do make a successful sale in the first call times the probability they do not make a successful sale in the second call. So in this case, this would be I got to make sure that I get this right. Yeah, 0.16 plus 0.16, that would be 0.32. And then what's the probability that they would make 2 sales in a given day? Well, that would be 0.2 times 0.2, 0.04. Now what we notice here is that the probability that they will make a success or a failure has to sum up across all probability states. So the probability that they'll make 0 is 0.64. Probability that they'll make 1 is 0.32. And the probability that they'll make 2 is 0.04. We notice that we add these up and we can see that we've covered all possible occurrences.